We're going to do the basics of adding and subtracting rational expressions. Before I go through doing this, I want to give you the basic rules of adding and subtracting fractions first. So we're going to do some very simple examples so you get the concept of it, and then there'll be later videos on doing ones with algebra in them. But right now we're just doing the basic rules, and I'm going to give you some different cases of each one of these so that you can see when I start throwing an X in it or an A or a B or a C that it's following the same rules. Here's are the basic rules. You must have a common denominator to add or subtract fractions. I think everybody, if I were to ask anybody in the room, everybody would know that, but that's a must. So if we don't, then we have to find the common denominator by finding the least common denominator by factoring. I call these where you're going to be using some smart ones in this step, and I'll show you what that means. The third step is we're going to combine our numerators, and I always say they're in love because you only combine the numerators. You do not touch the denominators once you find a common denominator. I want to caution you here, watch for the negatives, because when you subtract, it's like adding a negative, and you have to make sure that you distribute it. So this is important here. The last step is simplifying. This is totally opposite of what we did when we multiplied and divided fractions. We could simplify right off the bat. Here, it's your last step. We have to make sure it has a common denominator, and then we have to make sure that we've combined them, and then we factor to simplify at the end. All right, case number one. This is the most easy and the nicest one. Let's just put it that way. So here I have common denominators. That's case one. You're like, yes, I don't have to do anything. So I have 2 sevenths plus 3 sevenths. All I do is, because the denominator is the same, I combine the numerators. I have 5 sevenths. If I subtract, it's like adding a negative. I have 2 sevenths minus 3 sevenths. I leave the 7 alone, and I say 2 minus 3 is -1. So the answer is -1/7. So you're like, okay, that's easy. I knew how to do that. And that's fine. I just want to let you know that's the first. So if you have common denominators, you can go right ahead, combine your numerators. And then I look when I'm done to see, can I simplify that anymore? In this case, I can't, so we're good. Okay, case 2. Not common denominators. Now the last 3 cases all have to do with denominators that are not common, because that's where the algebra comes in. So I picked a problem, 3 sevenths plus 2 over 21. Well, most people would say, oh, 7 goes into 21, I know how to do this. That's fine, but let's go through why it works that way. Well, first of all, here's 7. There's the only factors of 7 are 1, but 21 is 3 times 7. When you say 7 goes into 21, it's because it's one of the factors. So now I know I can find a common denominator of 21 because 7's one of the factors. So underneath, I'm going to set this up, and I'm going to leave this as 21 because I can use that, and then the 2 will stay. So that fraction actually doesn't change because that's what I'm going to be using. Now here's where the smart one comes into place. I know that the denominator is 21, or if you will, 3 times 7. So I look at this, I already have the factor of 7, what am I missing? Well, I'm missing the factor of 3. So this is what I call a smart one. I have to multiply this fraction by a 1, but I want to be smart about it. I want to pick something that will help me, so I'm going to use 3 over 3, because 3 divided by 3 is 1. Then I say, okay, 3 times 7 is 21, so that helps me. Then I do 3 times 3 is 9. Now this will reduce back down to this, but we don't want it to. We want it to stay this way. So now I can combine the numerators. 9 plus 2 is 11 over 21. Then I look at it. Can I simplify it anymore? Nope. So we're done. That's case 2. Case 3 also doesn't have a common denominator. And what I picked here was 3 sevenths plus 2 thirds. Now, here I can't say 7 goes into 3 or 3 goes into 7 because the only factors of 7 are 7 and 1 and 3 and 1. So in order for me to find a common denominator, so I'm going to put it underneath here, I have to multiply those two. So my common denominator is going to be 21 or 7 times 3. Okay? Now here's where your smart one comes in. All right, I know that this is 21, if you will. I say, okay, I have a 7 in there. What am I missing? I'm missing a 3, so I'm going to use a smart 1 of 3 over 3, and I'm going to multiply that fraction by that. Now I have the 21 in the denominator, and the top is 9. The numerator is 9. Here, I have the 3, but I'm missing the factor of 7, so that's my smart 1. That's 7 over 7. There's my 21 in the bottom, and it's 14. Now, I just combine the numerators, and 9 and 14 is going to be 23 over 21. I look at it, can I simplify it? Well, I could write it as a mixed expression, but there's really no other simpler way to write it, so we'll leave it as an improper fraction, and we're done. So this case, you had to multiply the denominators to get your common denominator. Case 4 of not common denominators. This one is a mixture of the first two cases. So I have the fraction 5/6 plus 3/4. 6 doesn't go into 4, 4 doesn't go into 6, if you will, or factors of it. So I'm going to factor this to see what this is. This is 2 times 3, and this is 2 times 2. Now, a lot of you are saying, oh, I could do 24. Well, you could do 6 times 4 is 24, but you want to find the least common denominator, meaning is there something smaller so you don't have to simplify so much at the end? Well, if you look at it, I need to have 2 2's at least and a 3. I actually have 3 2's, but you don't need all 3. As long as I have 2 here and one of the 3's, I've covered all the bases. So my common denominator is going to be 3 times 2 times 2, 3 times 2 times 2, which is actually 12. And 12, 4 and 6 go into 12. So 24 would work, but this is actually a smarter way to do it because the fraction's not going to have to be reduced at the end as much. So what am I missing here? Well, I have a 2, I have a 3, I'm missing a 2, so that's my smart 1. So that's going to be 10. Here I have the 2 2's, but I'm missing a 3. So it's going to be 3 over 3 is my smart 1, 9. So my answer is going to be 19 over 12. And that can't be simplified anymore, and we're done. This is the basics of adding fractions, and those are the cases that I want you to know.